Sabi Africa. No Africa. No Africans. Pioneering role in science, engineering, and technology.
Sabi African Network, illuminating Africa's narrative as pioneers in science, engineering, and technology.
Indigenous textile pattern algorithms encoding cultural data in African textiles. Do you know when a Ghanaian kente weaver sits at a narrow loom, she is not just making cloth, she is running an algorithm. Each stripe, motif, and color follows precise transformational rules stored in human memory. Over 300 kente patterns act like named functions. Adinkra symbols are an alphabet with layered semantics. Today we will show you how African textiles are living information systems like mathematics, compression, and cultural code woven together. Long before formal fractal theory, African makers used recursive rules to grow complexity from simple seeds. Imagine a motif, apply a scale, rotate it, place copies in a pattern, then repeat. That iterative recipe is fractal thinking. In practice, it is contractive affine transforms, scale, X, rotate, X, translate, repeated n times. The visual outcome matches what computer graphics call recursion. Kente structure is modular. Weavers compose 10-15 cm strips. Each strip is a function that returns a motif sequence. Strips are stitched like concatenated array segments to produce a cloth. Color vectors act as semantic parameters: gold, royalty, green, and renewal. So a single weave encodes pattern family, color vector, stitch order, a multidimensional data tuple carrying political, historical, and social payloads. Adinkra works like a compact hierarchical coding system. Each stamped symbol maps to a literal icon, then a proverb, then a philosophical principle. That is a three-layer encoding: glyph, phrase, and ontology. Because stamps are placed on a square grid, the cloth becomes an addressable memory. Different symbols in different cells form messages with spatial grammar, like a low bandwidth but durable database. From an information theory view, textiles are clever compression and replication systems. Visual motifs compress stories into symbolic tokens. Color palettes add parallel channels. Durability and portability reduce loss. Textiles survive humidity and migration better than many paper records. Apprenticeship distributes knowledge, so the schema is not centralized. It is replicated across nodes of a social network, making data resilient to single-point failure. Algorithmic design is not limited to cloth. Hairstyles like Yoruba cornrows are recursive. Define a base braid, apply a branching rule, and iterate. In algorithmic terms, start with seed S, rule RS, new strand positions, and loop until length L. The human body becomes a state machine applying local rules to generate global structure, a form of embodied computation practiced daily. Researchers and educators have translated these practices into teaching tools. Small looms and stamping workshops turn abstract algebra and geometry into lived practice. Software can simulate kente rules, grid coordinates, iteration counts, and color vectors. When students map familiar cultural algorithms to formal notation, they internalize concepts like recursion, symmetry groups, and affine transforms far more intuitively. That is pedagogy that respects knowledge lineage while teaching modern computation. Textile practice offers real sustainability lessons, small batch production, local materials, renewable dye sources, and skill-based manufacturing that avoids heavy automation. Design patterns, both aesthetic and organizational, prioritize resilience, modular production, zero-waste material cycles, and social knowledge transfer. Modern designers and engineers can adopt these patterns to build low-energy, community-scaled systems. Understanding textile algorithms informs modern design and technology. Fractal patterns in kente influence computer graphics and textile engineering. Understanding mathematical structures allows contemporary designers to generate authentic variations rather than copying historical examples. Textile traditions offer sustainability lessons. Traditional methods operate at appropriate scales using local materials and renewable energy, human power. Knowledge distribution through apprenticeship creates resilient systems. Encoding cultural data in functional physical objects demonstrates sustainable information storage. No electricity, no format obsolescence, and no data loss from crashes. The story we leave with is simple but powerful. These textiles are not quaint relics, they are engineered knowledge systems. Recognizing them as mathematics and computation reframes education, design, and cultural heritage. Preserve apprenticeship, translate rules into teaching tools, and apply Indigenous design principles to modern sustainable systems. When we do, we are not just admiring beauty, we are reading code written into cloth for generations. Share and celebrate Africa's computational heritage, woven in every thread.